Thanks. Yes, hi. I'm Martin from Zweigbergk. I work at Google on source control. And yeah, I'm going to talk about how Jujutsu uses Git. Oh, sorry. Yes. Yeah, and you have all heard about Jujutsu a few times already today. But, so I've talked about it here twice before at Git Merge previous years, but I'll give a quick introduction to some of the parts of it that we'll need as background for this talk. I'm not going to talk about all the features and stuff. And yeah, this talk will be a bit similar to Scott's talk from last year about Git Butler, how Git Butler abuses Git, because we do kind of the same thing. Yeah, so it's a Git compatible VCS. We have pluggable backends, storage backends, so you can store commits in Git, or you can store it in a database, for example, as we do at Google. And there are actually several kinds of backends too. We have one backend that stores commits, one backend that stores the index, or like what Git calls the commit graph. We have operations similar to Git Butler's operation log. So it's basically a log of all the operations that you performed on your repository. And there's one backend that stores that. And so you can like plug and play these different backends, kind of. The working copy is also its own backend. It has basically two methods: one to snapshot the working copy, take the files on disk, create a tree object from that, and one method to check out the different tree and write that tree to disk. So there's a standard local disk working copy implementation, and we have at Google we have a VFS, virtual file system working copy that takes advantage of like asking that implementation, that working on the virtual file system, what the modified files are, and so on. And there are two production-ready commit backends. We have a bunch of test backends and stuff, but one is the Git backend, which like everyone outside of Google uses. And then we have an internal commit backend that stores all commits in a database at Google. And like the JD core library basically doesn't own any of the contents of the JD directory, except for like a few files that just tell it which backend implementation to load for this particular repository. So like at Google, for example, .jd contains like 260 bytes, something like that, that just indicates that use the Google backend basically for all of these backends. Yeah, so when in the Git backend that we use outside of Google, we store the commit objects as regular Git commits. The data model, JD's data model, is very similar to Git, so it's pretty straightforward to convert back and forth. And we use Git docside for that, for reading and writing commits and trees and files. The commit object, the commit ID we use is simply Git's commit ID. We have our file IDs and tree IDs are scoped to a path, so it's different from Git. So the Git backend simply ignores the path that we pass it. Yeah, to prevent GC, Git's GC from garbage collecting our commits. So as you may know, JJ doesn't force you to have a branch pointing to your commits. It keeps track of all your visible commits, and you have to explicitly abandon them when you don't care about them anymore. But since we don't create branches pointing to them, Git would garbage collect them, but we added this ref/jd/keep/something pointing to commits to prevent this. We have this change ID header. I don't know if you know what change ID is. Change ID is it's simply a randomly generated ID that identifies a change as a commit as it's rewritten. So if you amend a commit, it keeps the change ID, and you can continue to refer to the commit by this change ID. Yeah, so as Scott talked about, we store this in a, now like a few of us have agreed on a standard commit header. So the Git allows you to store these like custom headers, and yeah, as Scott said, like some tools preserve them, some don't. Yeah, and we also store some of, or at least historically, we have stored some of this information outside of the actual Git repository. We have our own storage where we can store a map from commit ID to some additional data that we keep, which has historically been this change ID. We store some predecessors if you rewrite the commit. Store conflict information there too, but like all of this we have either gotten rid of or moved into the Git commit object, so this is being phased out. Conflicts, it's been mentioned a few times today already. I think like we support this concept of first-class conflicts where you can store conflicts in commit objects. And that's stored in this JJ:trees commit header, similar to that change ID header. Since like, yeah, since this is just will not be Git remote will not be able to interpret this, but like we don't allow the push commands to push this to a remote anyway, so that's fine. Yeah, and the how the conflict is conflicts are represented by basically the inputs trees that were merged, that were part of the when you merged or rebased a commit. We store the inputs rather than storing conflicts markers, something like that. And those trees are stored in this JD trees header. And we also, to prevent GC, we store the involved trees in the roots tree, and like in a weird roots tree that contains all the participating trees as direct children. I'll show an example later. Yeah, and as I said, that's to prevent GC, and it means you could potentially push and fetch, which we don't currently allow. Yeah, so here's an example of what commit objects might look like when there are conflicts. There's the JD trees header, which mentions like 3 different trees here, and these are like also if we list the contents of the tree, you see that these are the same same roots trees that are mentioned now in this new fake root tree, and we have a README just like Git Butler does that tells you what this weird tree is about. Yeah, so the operations store, we have this log of all the operations, so you can go back in history and look at what your repository looked like in the past, and you can undo operations and restore your repository to what it looked like before. And the stuff we store is the bookmarks, which is basically Git branches, tags. We don't have any commands to set tags yet, but we can import them from Git at least. As I said, we don't require you to create branches pointing to commits, so you can have, instead we keep track of all the this set of visible heads or leaves of the graph. And also, the working copy commit has probably come up already, that we represent the working copy by an actual commit. So we have a pointer to that, and we also support what Git calls work trees. So this is actually a map from, or like a set of different working copy commits in each work tree. Yeah, and this is stored in a very simple storage, not very effective, not very fast, but good enough. Where it's very similar to Git's loose objects storage. And yeah, so even if you're using the Git commit backend, we still use this simple native default format for refs. So we don't actually store. We don't update the Git bookmarks when you create a book. Sorry, we don't update the Git branches refs when you create the bookmark in JJ. And we don't have any support for pushing these operations yet. Yeah, as I said, we because we don't export these. When you create the bookmark, that does not get represented in the underlying Git repository, even if you're using Git. So we provide some commands on top that will take care of that. Like, so you can, because if you're using Git repository, you will obviously need to send these commits, create branches, and interact with someone else eventually. So we provide a few commands to import and export these refs. So the JJ Git import will read all the Git refs and find branches and tags, which is basically all we care about. And we import them into JJ's operation log and write the new operation. And similarly, like there's the export JJ Git export command, which will look at all the recent changes to our bookmarks and, well, only bookmarks basically, and export to Git as Git refs/heads, whatever it is. And for that, we use Git Oxide as well. But like these commands, you basically never need to run as a user. And I'll get to that soon, why you don't need to run it. Yeah, so for fetching and like interacting with Git remotes, we have other custom or Git-specific commands. There's the JJ Git clone and fetch and push. So for example, you can do JJ Git push -c XYZ, where XYZ is a change ID, and that will create a new bookmark for you that points to this XYZ commit, and it just comes up with a name. And then it pushes that, exports that to the underlying Git repository, and then pushes that to the Git remote. So that's why you don't need to explicitly export the bookmark. And yeah, we used to use libgit 2 for all these remote interactions, but we had a bunch of problems with authentication mostly. Like it used libssh2, and most people Git uses OpenSSH, and so it did not respect your .ssh configs, for example. So we switched to just subprocessing to Git, and that has solved all these problems. Yeah, and yeah, so these commands also, like there's the git fetch command, for example. It obviously it calls git fetch, and then it does an automatic import of the Git branches that it fetched from the remote. at the end. So that's how we avoid the how you don't need this JJ-Git import. Yeah, so the Git repository can be stored in any directory. So when you're using Git backend, there is a real Git repository somewhere, of course. It can be stored inside .jj, or it can be like stored somewhere outside in a completely different directory, or it can be stored as a sibling to .jj, and if in that configuration we call it the collocated repo or collocated workspace, and we like the CLI treats this case differently and like does an automatic import at the beginning of Git refs to bookmarks and tags at the beginning of every command, and export at the end of every command. I think I have some more details about that soon. Yeah, so this is the life cycle of almost all commands, ignoring the Git integration. So at the beginning of any command, we snapshot the working copy, which may result in a new commit, and maybe rebase descendants too. Then we like run the command rebase or whatever it does, acts on these commits, and treats the working copy commit just like any other commit. And then, like when the command is done, it asks some common logic to update the working copy to match, the files in the working copy to match the new working copy commit if that was affected by the rebase or whatever it was. And so when we're in this collocated workspace, then we add a few steps for the Git integration. So at the start, when we snapshot, we first import the Git head ref, or symbolic ref. Then we do the snapshotting. We export refs to Git at this point too, because there could be bookmarks that pointed to the working copy, and now the working copy was rewritten by the snapshotting, so now we need to export that back to Git as a branch. Then we import any changes that had happened before the command from Git, and then we run the command as usual, and we instead of just updating working copy, we first export the Git, update the Git head if that needs to be changed. We export Git refs, and then we reflect the changes in the working copy as usual. Right. So the working copy, as I said, like when we at the end of a command, we update the head, Git head, to point to the working copy commits first parent. So we generally leave, or maybe always, I don't quite remember, always leave the Git repository in a detached head state, because we usually don't have a branch pointing to your working copy, or even its parent. Yeah, we make the staging area match the head, except that when there's a merge, we populate the multiple stages, so it looks like you have merge conflicts. Like when you have merge conflicts in JJ, you have this. You can see the same merge conflicts if you run git status, for example. We also set this intent to add for new files. So if you run, the goal of all this is to make git diff and JJ diff match as well as we can. So if you do, that's why we use the intent to add. So Git will show the diff for these added files just like JJ diff would. Yeah, we don't support collocation of work trees yet. There's a pending PR, but I think it's pretty stalled. We have end of line conversion, so you can have use just regular line feed in your repository and CRLF on disk, for example. Yeah, and that's not, we have our own config for that, so it's not, we don't use the Git config for it, and it's not specific to Git either, so like you can theoretically use that with internally at Google, for example. Yeah, configuration, we deliberately don't care much about Git's config because we want to work in with non-Git backends too. The only one I think we respect is this core.excludes files where you can point to your global git ignores file. And then like the JJ Git remote commands, they respect the Git's remote configuration because they just call Git. That's all. Thank you. Questions?
I'm still not clear if JJ actually needs GC or not.
We do have GC. Not sure what you mean by needs GC. But
Like, is it ever going to get to a point where a client will need like GC locally, or is it,
so the operation log means that we keep pointers to all these working copy commits and like basically every commit you've ever seen in your repository. But we do have a command to abandon old operations. So you can abandon old operations and then you can run the JJ util gc command, which will figure out what are the current still reachable objects. And
you never need to reorganize like the API?
well, yeah. Yeah, as I said, like this, like the operation storage is very inefficient, but so far it's been good enough.
A little dumb. Do you ever have any issues with keeping a bunch of key reps, like having open fetch specs and push a bunch of capital or something?
Well, they should never be pushed, I think. You mean push to remote?
Yeah, if somebody has like a very open push spec, right?
Oh.
Whatever comes up, or like
no one has complained about it. Yeah. We don't push it on when you run the JJ git push command, but if they use some git command, I suppose they could. But yeah, no one has mentioned it.
Sort of to that end, have you looked at its recent objects for GC, sort of like otherwise unreachable objects?
Yes. I think so that you need to configure a callback, and we would have to have git callback into JJ to figure out which objects are reachable, I think. We looked at it, and it did not seem to be a good fit for some reason that I can't remember. Yeah.
You guys consider using Git notes at all to store things and not lower the downside?
We, oh, right, yeah, sorry. So I mentioned this custom storage of change that we use for change IDs and conflicts and stuff before. Before we had that custom storage that's now being phased out, we used Git notes, but it was just way too slow after a while. Even with the kind of compaction, I forgot what it's called, but yeah.
You mentioned in your slides that you switched away from the Git to back to subcommits because of authorization issues. Can you see more what those issues were? You switched away from libgit to subcommit because of authentication issues. Can you say more what those issues were?
Yeah, oh, sorry, I've forgotten to repeat the other questions. This question was, what were the problems with libgit 2 authentication? Yeah, it was, I think the main problem was that it uses libssh2 instead of OpenSSH. So, and libssh doesn't care about your .ssh config, I'm sorry. No, we used to. No, for push and fetch, we used to use libgit2.
So in other words,
also Git has credential helpers. Some people push to HTTPS and get credential helpers, but this doesn't support that.
Yeah, credentials help. Yeah, just repeating what Ilya said. Yeah, credentials helpers is another reason, and remote helpers, I guess, too. Yes.
So the state that's not backed in Git, do you sync it when you're using the non-Git backend for it, or is it never synced between machines?
Sorry, do we use it when?
The state that's not backed in Git, like
Yeah.
let's say a wrong-click in progress of being resolved, when you use your own backend, do you sync it across machines? Or is it like always purely local?
You mean like, I think the question is like when you're using a non-Git backend, can you push that to a remote?
Or does it somehow get synced in some mechanism?
So it depends on the backend. At Google, with Google's internal backends, the commits are actually, they're stored in a central database, so you don't need to push or anything. They're always available. You can just, like, if you create a commit, I can just JJ new, to create a new commit on top of your commit. But yeah, so it's up to the backend. You may need to add like a new JJ, your backend, something push. Anything else? Yeah. Thank you.